Hello, this is Paul from Tech. In this lecture, we're going to deal with the other trig integrals, miscellaneous. So why is it miscellaneous? Because we cannot give you exactly guide. Okay, so how to do? As the first two we discussed for the power of sine and cosine, the powers of tangent, secant, the power of cotangent, cosecant. Is totally different as that. There is an exact guideline for you, but here we do not. No common strategy. Except one. Okay, reduction formula. Remember the previous lecture we already discussed that. Okay, so we have, but others. Okay, so no. So how to do? We have to try different identities, trig identities. You remember? Or probably you can try substitution method, or you can try integration by parts. Okay, or with you ingenious. Okay, so do some kind of a trick or tips. So all we need to do is just try and try. Don't give up. So try this one, you cannot go try another one. And this usually is the most difficult part because no guide for you. I show you, I think it's 4 questions. Okay, I was going to show you 4 questions. See, the first. Okay, we're going to tangent. It's a single function here, right? So how to do? If you know how to do tangent, you use the same later. Okay, if we get the idea. If you get the idea, it's the same to do cotangent. So how to do? We have a very basic identity, which identity we can make this to sine and cosine. We call the quotient, right? Okay, so the idea for this is for this integrand we can do what? So I can make this into see, is tangent x equals what? Sine x over cosine x. This we call the quotient identity, right? So over here is a quotient identity. Okay, this is one identity. If we have this, okay, I make this, and later we know how to do substitution. Okay, so can we look at if I put this integral to here? Okay, it should be like this. Do integration sine x over cosine x and dx after we do this substitution. So now can we make a after we make this manipulation? Okay, this is just the quotient identity. So now we should know how to do substitution. You did this before, right? Can you substitute the sine? No. Okay, we can substitute the cosine. The bottom. Okay, we can substitute the bottom. U equals cosine x. Why? Because we substitute the du equals negative sine x times dx. So can make a very, very easy integral. So what is the very easy one? Can we see? The bottom is 1 over u. What is sine x dx? Okay, I put it here. So you can find out what is du. Du is negative sine x dx. See? Sine x dx, right? Is negative du. So we times negative 1 times du. Okay, it's negative du. So now you know this is a reciprocal, right? It's easy. We have a basic formula already. Is what? Is a ln function absolute value at u. Okay, but it is negative. I put it out. Okay, so put it out. Ln, the basic formula of integral. This is u, and then don't miss C. Don't stop it here. Okay, one more step. Back substitute. Okay, back substitute. We will have the answer is negative ln. U is cosine x, so we put the cosine x, and then plus c. Okay, you can stop it here, or if someone like, you know, we have a power rule. This is a power. We can exactly put it back to the power. If we put the power is 1, see, if I do, someone you can stop at here, or if you like, you can go one more step to make it ln absolute 1 over cosine x, right? This power goes to there, negative 1's power is the reciprocal. What's this? we have a reciprocal, right? Reciprocal identity. If you like, you can use this, which means secant x is a reciprocal of cosine, right? If you put this is secant, okay. So this time, if someone like, you can go to this absolute value of secant x and plus c. That down. This looks a little bit simple than that. Or someone said this is simple, whatever. Okay. So this is D1. All the idea is what? It's just to manipulate the integrand. Okay, manipulate the integrand, the integral function. Use the identity. Okay, use the quotient identity. So how about this? You know, right? E also quotient. This quotient should be what? Cosine over sine, and do another substitution. Okay, you're going to try. So I will not do that. One more. So can we look at this? Still single function secant. So if you know this, the later you will know how to do this. But this time is a little bit complicated. Okay, so a little bit of trick. Okay, I directly show you. Okay, so this method proposed by someone. Okay, in the history, very famous. Okay, so you can go Google to check. See, can we see? We have to manipulate. All we need to do. This is too simple. Okay, we cannot get the answer. We will make it complicated, but don't worry. Make it complicated, we can solve the questions. All we need to do is do this. We have to manipulate this integrand. Okay. So how to do? Let me show you here. Okay, is somebody proposed. Can you see? It's how good? How good is this manipulation? And we doing times something. See, times a complicated one. Tangent x, and the secant x plus tangent x and dx. Oh, you say, why is it very strange? You are going to make the problems so difficult. Okay, so first, this is correct, right? Because what? I just times 1. This is 1. Times 1, it did not change. Why we times this? Please look at one more step. One more step, you will see something. The bottom secant plus tangent to the top. This time data distributor, we have a secant square plus secant x times tangent x and dx. Have you find something now? Okay, substitution. It's a very strange substitution for the all denominator. See, if you do substitution for this, u equals secant x plus tangent x. How do you think you take a derivative? Okay, so that's going to take a derivative. So what is du? And the take a derivative goes to what? Secant x times tangent x. How about this? And this is going to secant square. Okay, this is the derivative. And then we need to times dx. Complicated, but don't worry. Can you compare to the numerator? Secant square, secant times tangent, secant times tangent, dx. Okay, all the terms on the top is just the du. You can see how good. Okay, so after we do the substitution, it's amazing. Okay, it's really, really amazing. Somebody proposed this in the history. Okay, now if we have, so now it's easy. So all this goes to du, and the bottom goes to u. So that's 1 over u and then du. Can you see how easy? The reciprocal, right? And then what do we have? Ln absolute value of u plus c. What is u? Back substitute. Okay, just the back substitute. So we will have the answer. Ln absolute secant x plus tangent x plus c. And look at the functions, complicated, okay? It's really complicated. However, see, this is manipulation. Okay, so we get the answer. If you know, this is very, very good, right? But it is not easy, really not easy. This is the hardest part. So we can say it's hard, okay? You know it's hard. So how to do this? I will not going to show, okay? So you know how to do. Also times kind of 1, but different, okay? So you have to use what? Cosecant and the cotangent, okay? So you can try by yourself. Okay. Look at one more. Look at this. Look at it's simple. However, it's not easy. All we need to do is the similar idea, okay? So for the integrand, we have to, let's see, we have to manipulate still this integrand. So make it easy. Looks easy, but not easy to do integration. How to make? So we have to use what? Pythagorean. Okay, so we use this equals secant square minus 1. You can try, right? At the beginning I said we can try. Tangent the third power y equals to the second power. We can separate the one tangent. So we have a tangent square. Tangent square will make this. Okay, all we need to do is make this, and later you will see we can find this solution. Okay, and find the answer. Now we move on. If this is going to here is this integral, we make a 1 and then times tangent square. I use that is secant square minus 1 dx. Okay, that's the Pythagorean. Then distribute. Okay, so we separate it into 2 integral. So into 2 integral the first, tangent and secant square. Secant square dx. The second is minus tangent x dx. Okay, we make it complicated, but don't worry. So look at the second. This we know already. Okay, the previous the questions, remember? So we already know up here. This is a known results. We know before, right? If I should use the results is here. Tangent, I think is the previous, the first questions. Okay, we did here. Sorry. So here is dx equals what? Equals ln absolute value secant x plus c. Okay, so this is the first from where? This is from Q1, the first questions we already have. Okay, means don't worry about this. So now worry about that. Don't worry, because this is the basic type. So we have tangent and secant put together, right? Okay, which one? Can you see? In the secant square, this is even. This belongs to that, or also belongs to this is odd, right? No matter which one, tangent secant put together, either way you can find this solution. I use this. This is even. If that even, what we need to do substitution. See, you put this together. This is a d tangent. Okay, means what? Do this substitution. That's nothing new. Okay, so is u equals tangent x. Okay, can you see what is du? We have is secant square dx. That's exactly what I highlight. This is d tangent x du. Okay, okay. So if you plug in, so now we will have, if you plug in, is here. So this is u. This is du, right? How easy. Okay, this is the power, and then minus I just still copy here because we have the answer for this. I leave this to the end. What this we do know is 1/2 u square, right? I still leave this to here. The last step, what is u? So we can back substitute, right? We can back substitute, and then this we can use the answer. We can use the original known results. Plug in, we get the answer. See what it is? 1/2. This is a tangent. This is tangent square. And what this? Okay, what this? This is minus the capital formula. These results here is secant x absolute value plus c. Yeah, it's complicated. You can go to verify this ticket derivative, you can get this simple one. Okay, so that's one example. So, and not easy, still not easy. Can you see? Still not easy. Okay, still not easy, but just try. Just try. Okay, try. If you try this and you get the solution, that's good. Let me see. One more. Good. I have one more example to you. How about this? This is the last example. Sine 4x cosine 5x. 4 and 5 cannot merge together, right? So this you cannot do substitution, you cannot do integration by parts, not okay. But you do have a trig identity, okay? You do have a trig identity. Which trig identity can put these two angles together? Okay, do you remember in trigonometry we do have a 1? All we need to do is still okay, I put this. Still manipulate the integral. This time we have something to manipulate, which is this. This is a product. Remember now? I think you remember something, right? Product to sum. This formula can merge these two angles together. Okay. I copied the formula here. What is the formula? Sine alpha cosine beta. Remember, 1/2. I copy. If someone you remember this, that's better. If you don't remember, it's okay. I put it here already. The difference of the angle. This is the sum of the angle, and this is half. Okay. So this formula exactly follow this. Okay. So now we just plug in. See, plug into the formula. Now what do we have? So this is 1/2, right? And this is the difference of the angle. The difference of the first angle minus the second, which is negative x. This is the sum of the angle. 4x plus 5x is what? Is 9x. Can you see? Okay, good. Only one step. Okay, only one step. Manipulate. This is easy, right? And this is also easy because it's the single power. One more, so we can make it a little bit more easier. See, and the negative x. This is odd, right? Sine is odd function. That means sine negative x equals negative sine x, odd function. If you plug in, you get a little bit easier. And also this constant number we factor out. Okay, the coefficient factor out, and then it's integral. So here what do we get? Negative sine x plus sine 9x. Okay, so now easy, right? This is the another value is cosine. This is a cosine 9x, but we need to make the coefficient. Okay, now all we need to do is just put the first, this is a cosine, right? See, cosine take a divided goes to negative sine. What is this? Should it be what? Should it be cosine at 9x? But we need to put the coefficient. This take a derivative goes to negative, so we need to make a negative. This take a derivative goes to 9, so we need to make a 1/9. Okay, if you make this, see, can you verify this take a derivative goes to definitely that, and then don't miss the last c. Okay, plus c. This is not difficult, right? This is easy because we have the formula directly. Okay, that's the answer. I hope you get some experience. Thank you.